This is going to be Chapter 13, Section 1, Part B. So 13.1b. In Part A, we covered dissociation of ionic compounds. And in this section, we're going to cover ionization of some of our molecular compounds. So ionization, this is where you have your ions are formed from a solute molecules by the action of the solvent in the process. So the solvent is going to pull apart the molecules in your solute. And when a molecular compound dissolves and ionizes in a polar solvent, ions are formed where none existed before. Hydrogen chloride is a molecular compound that ionizes in an aqueous solution, and HCl contains a highly polar bond, and this is going to be the equation for it. So in our dissociation of ionic compounds have ions. Usually a metal is involved, so a metal and a nonmetal, a metal and a polyatomic ion, typically. For ionization, when we're talking about molecules have covalent bonds, and it's talking about the polar covalent bond. And covalent bonds are going to be formed from two or more nonmetals, or nonmetals and metalloids, because we'll treat our metalloids like nonmetals. So no metals involved in molecular compounds, and with us talking about ionization. So the gist of this one right here, just so we are all on the same page, cations do have a positive charge. Anions do have a negative charge. Your ionization energy, this would have been talked about back in Chem 1, but ionization energy, the trend for ionization energy, or IE1 as it's also known as, IE1. The trend for ionization energy going across a period is increasing. So that trend across a period is increasing. If you're going down a group, it is decreasing. And we can have additional ionizations. So ionization is talking about, it's the energy involved. Not just energy involved, but it's going to be the energy required to lose one electron. So that's your IE1. But if you go through additional ionizations, such as an IE2 or an IE3 and so on, so what's the energy required to lose a second electron or a third electron? So that is a thing too. And this also talks about your electron affinity trends. The trends for it going across a period are the same as ionization energy, and that is increasing. So ionization energy, we are losing electrons. Electron affinities would be gaining electrons. Your metals want to ionize and lose electrons. Typically, nonmetals prefer to gain electrons because of their placement in the periodic table. Now, in this one, as they're comparing dissociation and ionization, so as a reminder, dissociation is going to involve the separation of ions and an ionic compound, and then your ionization, which we'll focus more on here. Ionization is going to be compounds that can dissolve into ions, but it's going to be your polar molecules. That will dissolve into ions. And if I were to add a third one on here, it won't be talked about necessarily on any of the slides within the PowerPoint, but we do have a third one called molecular solvation. Both of these, your ionization and molecular solvation, both of them deal with molecules, But ionization deals with the breakdown of polar molecules. Molecular solvation is going to be dealing with, I would say in general, your nonpolar molecules. So again, a bunch of nonmetals put together for making it a covalent bond, but they will tend to be nonpolar, and they will not break down nearly as readily. And we will get to some of those percentages too. So with those percentages, your ionic compounds will break down essentially 100%. Polar molecules is going to be close to that 100% if they are very polar, but through molecular solvation, you're looking at probably a max of 5%. So the hydronium ion. Polar molecules that do ionize tend to release the hydrogen ion, that's H+, and this hydrogen ion will attract other molecules or ions so strongly that it will not exist alone. So the H3O plus ion is known as the hydronium ion. The hydronium ion, H3O plus, and you can tell that since the HCl was dissolved in water and that hydrogen ion have attached itself to give you H3O plus, that extra hydrogen, and it is called the hydronium ion. So again, your hydrogen ion likes to combine with water to form the hydronium ion. And a lot of our solvents, I said notoriously, are going to be water. So getting into electrolytes. Electrolytes conduct electricity. We do have a strength. We talk about them being strong or weak. Do they conduct electricity well or not so much? And it all boils around how well can I form ions. The better I form ions, the stronger I'm going to be on the electrolyte stage. So strong and weak to electrolytes do differ in their degree of ionization or dissociation. So the more they break into ions, the stronger their electrolytic properties will be. It's given you here some examples. NaCl, that is an ionic compound. AgCl is also an ionic compound. These are both going to be strong electrolytes because through dissociation they will basically completely break into your sodium and chloride ions. Weak electrolytes, you've got HF as being a weak electrolyte. Now HF is a molecular compound that does partially ionize. And then this is also a molecular compound, a form of sugar, but it's considered a non-electrolyte. So even though sugar will dissolve in water, the molecule stays intact on the whole. So the molecule will stay intact, where the other ones you can see that they do have ions that are floating around in solution with the water. So again, some of your ions are floating around in solution with the water. So a strong electrolyte, any compound whose dilute solution conducts electricity well, is due to the presence of all or most or almost all of the dissolved compound in the form of ions. These right here, hydrochloric acid, hydrobromic acid, hydroiodic acid, these are all strong acids, and any of your soluble ionic compounds. When we get later on to acids and bases, we will talk about the strength of different acids and bases, strong acids, weak acids, strong bases, weak bases. These right here are considered to be a few of the strong acids you will learn. So even though they're a molecular compound, they will ionize completely into the hydrogen ion and the corresponding, in this case, halide ion, the Cl, the Br, and the I-. And then all of your ionic compounds will dissociate. A weak electrolyte is a dilute solution that conducts electricity poorly, but it will conduct. This is due to just a few of the ions that are present once you've dissolved your compound. And some molecular compounds, that contain not only dissolved ions but also some dissolved molecules that are not ionized. And the example that they're given here, you just saw it on the 2 slides ago. Hydrofluoric acid, it's another acid, but it's not considered a strong acid. It is a weak acid. Will break apart into the hydronium and fluoride ions, but this is definitely a reversible reaction. You're going to have much more of your hydrofluoric acid in solution and not nearly as many of your hydrogen or fluoride ions in solution.